بسم الله الرحمن الرحيم الحمد لله والصلاة والسلام على رسول الله السلام عليكم ورحمة الله وبركاته. Thank you all for joining us for our conversation on Islam and AI. Our guest speaker today is a great friend of mine, Dr. Hidayat Ansari. He's one of our dear community members, and he's been working at Amazon as a machine learning scientist now for nearly a decade. He has a PhD in computer science from the University of Wisconsin, the other UW, where he also taught courses on AI algorithms and compilers. Dr. Hidayat has been doing this program actually in several different places, in Chicago, at the Darussalam conference, and also in Dallas at Epic Masjid with Dr. Yasser Qadi. So he's been, mashallah, going around and sharing his knowledge with everyone but us. But now he's, we finally convinced him to do it here. Inshallah, with that, without further ado, I'll leave it to him, inshallah. Jazakumullah khair.
Jazakallah khair, Imam Adam. Bismillah, alhamdulillah, wassalatu wassalamu ala ashrafil khalq, Muhammad sallallahu alayhi wa sallam, wa ala alihi wa sahbihi wa man wala. Assalamu alaikum. I want to talk a little bit today about artificial intelligence, how it's becoming ubiquitous in our lives, and the challenges and opportunities facing us as a community because of it. I won't have time to get into the depth of any one thing, but I want to get us thinking about them, and hopefully inspire some of us here to develop expertise and contribute to the field itself. Now, before we begin, just a very brief definition. So when you say AI, generally speaking, this isn't a formal definition or anything, but generally speaking, we're talking about computer systems, and I'll explain as we go, that are capable of performing cognitive tasks that we normally associate with human beings. When I say cognitive tasks, I mean things like perception, hearing and seeing, things like reasoning, comprehension, planning, problem solving, and also learning. These are things that we associate with human beings. By learning specifically, what I mean is you improve in the performance of some task given feedback on it. So that's what AI systems generally are. And AI is already quite pervasive in our lives. The way that pricing is determined for the things that we buy, the way that search engines know what we're looking for, the way that they personalize our search results for us, the way that we talk to customer service, the way that it figures out what we're saying, the way even that prison sentences are recommended in some counties, the way that a company decides if they want to interview you or not, the way that a company decides if they should give you a free trial for a product because they think you're going to buy it later, the way that fraudulent transactions are flagged, your Amazon recommendations, your Uber driver match. Your life is very likely touched by dozens and dozens of AI models every day already. And yet, there's a revolution that's been happening on the research side, and it kind of came to the forefront of public consciousness early last year when ChatGPT got huge. And we went beyond prediction to generation, to generating media like text and pictures. And we've all seen some really impressive examples. I'll go into some of them later. It's able to generate stories, summarize documents, and even write and debug computer code. People have used it to write entire khutbahs. And we'll go into why that may be a little bit problematic later. ChatGPT was able to pass the final exam of an MBA course at a reputable university. It placed in the top 10% of the bar exam. It can proofread your resume and write your essay. It can generate recipes for you. So while AI has been around, generative AI is a step function change. And what I mean by that is that it's a kind of disruptor. It's shaking the way that we do things, and it enables a vast medley of new things that we haven't been able to do before with computers or with machine learning. So I'm going to quickly go through some examples of what it can do. So I asked it, I was having a chat with a mufti a while ago, and we were talking about he's writing a paper on the harms of an interest-based economy. And so I went back and I asked ChatGPT to write me an essay on the harms of an interest-based economy. Because as Muslims, we believe that when Allah subhanahu wa ta'ala forbids something, He forbids it because it's actually bad for us, not just because He wants to. So we believe that riba is forbidden in our economic system because it leads to harm to individuals and families and communities and nations. It harms the way that money circulates or doesn't circulate in society. So ChatGPT is able to write a few paragraphs, and it talks about, you could read it on the screen, it talks about the harms of such a system, prioritizing short-term gains over long-term sustainability and well-being, talks about wealth inequality, disproportionate amounts of wealth and power, exacerbating social tensions, eroding trust in institutions, hindering social mobility, and ultimately weakening the fabric of society. And so some of these reasons may be behind the illah of why Allah has prohibited riba for us. But it's able to do this in a few seconds. I was talking with somebody the other day, giving him a ride back to Seattle from the east side, and he wanted to go to the Olympic Peninsula the next day, and he was asking for an itinerary. I'd been there a few times, so I was like, first you stop here, and then you go there, and then you go to the ocean, and then you go here, and then you come back. And it took me maybe 15 minutes of back and forth to come up with a good itinerary that actually fit him and what he was looking for. And then I went back home, and I decided to ask ChatGPT what it would recommend. And you can see that it does a pretty good job. It came up with a 2-day itinerary for the Olympic National Park. And it does pretty well. It pretty much follows what I told him the night before. And so we see examples of it helping with our productivity. And we'll get into that a little bit later. I asked it the same thing for Dallas, and it gave me a bit of sass. It said they couldn't do that for Dallas. I also asked it to generate a bash script, to write some code for me, to find and delete the largest files on my computer. And so again, in a few seconds, it's able to generate a script to do something. If you know bash, you can look at this, and it looks mostly right. I have a friend here who excuse me, has zero coding experience, and he wanted to write some code, or he wanted something to extract some information from a website, a very specific website. And so he used ChatGPT to do it. So he has no coding experience, and he's able to have a back and forth conversation with ChatGPT to write some Python code, to scrape that website. And it was a little bit difficult because the website used dynamic loading of text, and it used some pretty sophisticated things. And yet, he was able, with zero coding experience, to actually write a piece of code and run it and get the data that he wanted. So at the end of this talk, you'll have a high-level idea of how it is that we can generate something like this. I want to go through a few more examples. Text-to-image is another new and very hot area. You provide the machine with a text prompt. In this case, I was in Chicago, I was feeling a bit homesick, so I asked it to generate me a picture to make me feel less homesick. And so it decided that the thing that characterized Seattle was waterfalls. And so it drew me a picture of waterfalls in Chicago. Again, in a few seconds, right? I asked it again to generate a picture of a fighter jet at the fall of Constantinople in 1492. I asked it to generate an anachronistic image, right? The times don't match. We didn't have fighter jets 500 years ago. So this was an example of something where the places don't match, and this is something where the times don't match. You can generate pictures like this on your laptop now with some of the newer models. My point with these ridiculous examples, admittedly ridiculous examples, is to get our minds thinking about what people can generate and pass around. Right? Imagine if somebody generates a picture of the Pope at the Kaaba doing sajda or something. Imagine that picture bouncing around the WhatsApp groups. Right? I'm being ridiculous because I want to get the imagination going. Imagine your favorite imam endorsing a politician. Right? You can even make videos now. It's not all bad though. I don't mean to alarm everybody here. Imagine possibilities. Imagine Imam Adam or Imam Akram teaching a class or doing a khutbah and having it translated in real time in 20 different languages, into Malay, into Swahili, into Turkish, and French, and Russian. And it's not translated like it's dubbed or something. It's very natural. You can see their mouths moving the way that they would be if they were speaking that language. So imagine the possibilities that this opens up. uh, it's surprisingly also able to generate poetry. Not very good poetry, but poetry nonetheless. So one of my friends was in a playful mood a while ago, and he asked it to generate some poetry in the style of Imrul Qais, who's a pre-Islamic Arabic poet. And so one of his well-known poems is about a lost love. So my friend asked it to generate a poem in the style of Imrul Qais, in the style of that particular poem, but about a lost bowl of mansaf instead of a lost love. And you can see that it does a decent job. If you want to take a few seconds to read the translation, it's not great, but there's something there. And so he asked it to write 4 lines of the poem in the original meter and translate it to English. And obviously, because we're being frivolous here, we don't want to begin in the name of Allah. Another really incredible thing we're able to do with generative AI is to make proteins. Now, we don't really see this kind of hyped up in the media yet. I'm not quite sure why that is. But I think this is probably one of the most important applications of generative AI. About 2 years ago, the Institute for Protein Design here at UW published a paper in Nature magazine about how they were able to generate proteins in a wet lab based on a shape that they gave it. So typically, okay, so again, this is not a lecture on biology. I'm not a biologist or a doctor or anything, so I'm going to keep it very high level. But proteins mediate every single life process. And what decides the way or the function of these proteins, what decides the way they work is their shape. And their shape is decided by the amino acids that make them up. So parts of them are hydrophilic, parts of them are hydrophobic, and the way that the protein folds is determined by those 2 things and a bunch of other things. So you have a really large amino acid sequence, and you can't immediately predict how it's going to fold. You don't know what shape it's going to take. And the shape is what decides its function in our bodies. Right? And so before generative AI, we could not say that here's a shape that we want, and here's an amino acid sequence that folds into that shape. We could not do that. But generative AI allows us to do that. And so now we can bypass a lot of the original process, the lab process, that we needed before to generate proteins. We can just say that here's a disease, here's the antigen for it, and we want to make something that looks like it. And then generative AI can help you generate that protein. It's quite revolutionary. And what's more is that 99% of possible proteins, 99% of possible amino acid sequences don't occur naturally in nature. And so we're able to access the vast majority of proteins that we're not able to naturally generate. So now we can create antibodies using AI, and it helps us with generating sequences that match the desired shape. So we can directly create antigens to disease-causing pathogens. Typically what you would have done is you would have found somebody who had the disease, you would isolate some blood from them, isolate the antibodies, figure out how to generate those, test a bunch of different compounds, make your drugs, do the tests, go through the trials, and so on. It was a very long process. And now you can use generative AI to generate those proteins in silico, in wet labs. Now what this could lead to is gene editing technology. Maybe you can automatically produce proteins to rectify DNA errors that we have. Maybe you could use them to generate things that are able to rectify errors in our DNA that cause cancer, for example. Or if you want to edit genes, and if you want your child to have a longer nose, for example, or make them have dimples or something. This is what this kind of technology enables. You could develop personalized therapeutics using this kind of technology, designer drugs for any kind of living system. That's where this is going. And again, I'm just trying to touch on possibilities from different areas to get our minds thinking about what this means for us, and what this means for us as Muslims. Like, which parts of it are permissible, which parts of it aren't. And it generates a whole lot of other applications as well. Imagine telling an AI assistant, your own personal AI assistant, to write an email to a seller on Craigslist or Facebook Marketplace about buying something you want to buy. Or to call your barbershop and have them schedule an appointment. And your AI assistant just goes and does it. right? Generative AI, as we've seen, can generate its own code, its own algorithms. Today, you might need a whole team of software developers and a year of time to write any moderately large application. And when you do that, it can only do that one thing. If you want to write tax software for a dentist's office, you might need 10 software engineers and a couple program managers and a manager and a UI designer and so forth. And it might take them a year's worth of time. And at the end of that 1 year, you might have a buggy product. And you might have spent $1 million. And now imagine being able to generate that on the fly. Imagine applications where your computer can generate its own code, think through its own algorithms to accomplish something. It opens up a lot of doors. I have a friend on the east side who works in education tech. And I spoke with him early 2023. And he told me that his plan for 2023 was to take the products that his company produced, educational technology products, and translate them to 6 languages. That was his whole plan for his whole company for 2023. And he had lined up people to translate his content, and people to check it over, and people to make software out of it. He had lined it all up. And then ChatGPT comes along, and he can do this in a matter of hours by himself, without hiring anybody, without spending any money. And so it completely redesigned his roadmap for his company for 2023. It changed the way that he does business, and it expanded the impact of his work product. And then there's more stuff coming after this as well. I don't want to get into it, but then some of the hotter fields today that people are working on, there's things called agentic AI. There's embodied AI that's coming up. It's kind of building on this revolution of generative AI. I want to spend a little bit of time on how they work. Just peel the hood back a little bit, just so we have an overview of what's going on. And the point of this is to get a sense of where they'll be useful to us and where they won't. I'll talk about a few main pieces, and then we'll tie it all back together, inshallah. So computers, excuse me, obviously, they don't have an innate understanding of language. All they understand are zeros and ones. And so we need to find a way of representing language as zeros and ones. And so early on, what people did was they decided to represent language in terms of these language models. And so what they did very, very early on is look at pairs of words. So you look at 1 billion documents, you look at a few billion documents, and you look at all the sentences in those documents, and you look at which pairs of words occur together. So you take a sentence like, Seattle is known for cloudy skies. And then you take every pair of neighboring words in that sentence, and you count how many times it occurs. So for every pair in your entire corpus of everything you've digitized, you count how many times pairs of words occur together, how many times triplets of words occur together, and so forth. And that becomes your language model. That kind of tells you what you need to know about each word and how it relates to other words. Now, these are very, very basic language models, but they work pretty well for a lot of applications in the past. This is not quite how LLMs work, but it's a good way to start thinking about them, how words relate to other words when your computer doesn't have an innate understanding of what a word means or how it relates to natural concepts. And then the other piece is something called neural networks. It's an architecture that large language models use. And the way that it works, again, very, very simplistically, very, very high-level overview, the way that it works is that you take some data that represents something. Maybe it's a picture, maybe it's a sentence, maybe it's an MRI scan, maybe it's a set of numbers representing a debit card transaction, and you turn it into a numerical representation, and you pass your data through a network, right? And what I mean by passing it through a network is maybe there's some multiplications that happen, maybe there's some additions that happen to your numbers, maybe there's some function applications that happen, and you pass it through a network. And when it gets to the end, it represents something that is the result of your calculation. So the result might be something like, if you passed it a picture, the result might be a categorization for the picture. So if you give it a cat picture, maybe the result says this is a cat, right? Maybe if you pass it an MRI scan, the result says this is anomalous, or this is where the cancer is. If you gave it a debit card transaction, the result might be something like, this is a fraudulent transaction, this debit card is always used in Texas, it's never used in Virginia, and it's used at 3 a.m. in Virginia at a gas station that nobody's ever heard of. It's probably fraudulent, right? So that's what a neural network does. It takes in some data, and then it crunches it through some numbers, and then it gives you a decision at the end. Yeah, I think that's all I want to get into right now. And the way that it does that, the way that it produces the correct output for each piece of input is through a process called training. So the way that it knows what numbers to multiply, which ones to add, what kind of functions to apply, the way that it knows all of that is through a process called training. And again, all that it does, I'm not going to go through the math. This is a math light talk. But really, all it does is, where did I put this? Never mind. All it does is that you basically teach it like you would a human being. So you take a bunch of examples, and you know the results for those examples. So you have a bunch of MRI scans, and you know that these are anomalous and these aren't anomalous. So you take your example, you pass it through, and you look at what it says. If it's the right answer, you do nothing to it. If it's the wrong answer, you go back and tweak the weights until you get the right answer. And then you pass in another example. And if it's wrong, you go back and tweak the weights. And you do this a lot of times, right? You tweak the weights trillions and trillions of times until it gets you the answer that you want. Until you're confident that if it sees something in the future, if it sees a new debit card transaction, a new MRI scan, a new picture, a new sentence, it knows what the correct answer is. Okay, so that's the process of training a neural network. And the math of it really is just high school stuff. It's chain rule, it's derivatives, it's basic calculus, basic high school calculus, and matrix multiplication. The only trick is that you do it trillions and trillions of times. If you've heard the term deep neural networks, all that means is that you have your neural network and it has a lot of layers in between, right? That's all it means. I'll talk about scale a little bit later. And then the other piece is this architecture called transformers. So this is a very specific kind of structure, architecture for neural networks that was introduced in a paper out of Google in 2017, in late 2017. The paper is called Attention is All You Need. And this paper kind of revolutionized the way that we do neural networks for, especially for text processing. So the main idea here is that it's an efficient way of dynamically weighting the more important parts of a sentence. We couldn't do that very well before this paper, but now we can. And so you look at all the new models, Llama, Mistral, GPT, Falcon, all of these new models, they're all based on this particular architecture. And finally, the final piece that I want to talk about is word embeddings. When you read about LLMs, you'll see this term a lot, word embeddings or word vectors. When we see a word, we have a sense of what it means and what it represents and how it relates to other words and how it relates to real-life concepts. And so when I say word embedding, it's just a fancy way of saying that it's some numerical representation of a word. You take a word and you represent its meaning by a set of numbers. So that's called a vector or an embedding. And we want these numbers or these embeddings to have some nice properties. So if we pretend that these word vectors live in two-dimensional space, or a projected two-dimensional space, we want the relative proximity of words to reflect something about their meaning. So we want the representation for the word kitten to be relatively close to the representation for the word cat. And then we want the representations for cat and kitten to be closer to the representation for dog than they are to the word house, just because of the overlap of these concepts. And how do you derive these word embeddings and these word vectors? Again, you train it. So you have your giant corpus of data. You have every piece of text that's been digitized, and you look at how close certain words are and what context they occur in, and you train your embeddings to represent or to derive meaning and represent their meanings in this way. Generally speaking, these word vectors, they're not two-dimensional or seven-dimensional as on the slide. They're typically hundreds and hundreds of dimensions. Okay, so we're getting closer to the end of how LLMs work. We've seen that neural networks, they take in some data and then they give you an output. They predict some output. So with large language models, what are they predicting? And the answer is they're predicting words, right? So their task, the task that they're trained on, the neural networks we talked about had other tasks, right? We talked about neural networks that could find cancerous bits in MRI scans. We talked about neural networks that could flag fraudulent debit card transactions. But with large language models, the task is to predict a word given some context. So the task that they're trained on is, if I give you a set of 20 words, maybe 10 words before a word and 20 words after another word, and if I mask that particular word, can you predict what that word is? And I do this trillions of times. So I give it trillions of contexts and hide one word at a time, and I ask it to predict what is the word that should go in here. This is the task that they're trained on, right? You mask a word, you teach it, you tweak the weights if it gets it wrong, and you do this for billions and billions and billions and billions of words in your billions and billions of documents. The estimate is that these large language models are trained on roughly 10 to the 13 order of word tokens, roughly 10 to the 12, 10 to the 13 words. And so what these neural networks do, what these LLMs do, is that they generate a probability for every single word. So you might have a sentence that looks like, the best thing about AI is its ability to, and then you have a blank. And so what the LLM does is it looks at the previous 8 words, and it makes a prediction for what word should follow. What word looks like it fits here? And so it might say that is its ability to learn, or is its ability to predict. And what it does is that it comes up with a probability distribution for every single word in its vocabulary for what word fits in here. And then it chooses one of them, right? It samples from that distribution. So the reason that I went into so much detail is to show you that all LLMs do is that all they're trained to do is to look at some context and figure out what word seems like it fits here based on everything it's seen in the past, right? They're trained for one task and one task only. Given a set of words, make a prediction for the next word. Yes?
Can I ask a question?
Yeah.
So it's true, right, that Gen AI is as smart as its training, right?
Depends on the word smart, but yeah.
Right. So then what do you think of Gen AI training itself?
We'll get to that. Or maybe we'll talk about that later. So the way that it generates its predictions, when you talk to ChatGPT, the way that it generates essays or long streams of text is that it takes your prompt, it figures out what's the first word that should come after it, after your prompt. And then it takes all of that and says, what's the next word that comes after it? And then it takes the prompt and the first 2 words and then figures out the third word. And so it just does this word by word by word until it finishes the answer to your prompt. So it comes up with stories, recipes, itineraries, resumes, code. And so now that you know how they work, this should cause some alarm bells to go off in your heads, right? What about factuality? What about truth? If all it's doing is predicting what word seems like it fits here given everything I've seen in the past, does it care about if it's true or not? Does it care about if it's factual or not? It doesn't really, right? And we'll get into what that means. So if you bring it all together, a large language model is a very, very, very large transformer-based deep neural network that predicts a word embedding based on surrounding words. So you do it over and over again, word by word, you get to generate a very long stream of text. So this is really one of the main takeaways, right? They're trained for one task only, given a set of words, make a prediction for the next word. And obviously this introduces other questions about bias in the training set, right? You've all seen examples of these large models that if you ask it to generate a picture of a fast food worker, for example, it'll generate a picture of somebody with darker skin. You ask it to talk about Muslims, it'll stereotype Muslims a certain way, and so forth. I'm going to skip this slide on scale, or maybe I'll go through it very quickly. So the way that these LLMs work, there's about 1 billion parameters, 1 billion weights in that giant network I was talking about. And this is actually a little bit unfathomable for someone like me. All right, I was in graduate school a very long time ago. And if you had told me when I was beginning graduate school that you could train a machine learning model with 1 billion free parameters and actually have it do something useful, I would have laughed in your face in the early 2010s, late 2000s. Because it's inconceivable that a model with that many free parameters that we could find enough data to actually train it meaningfully. But the fact is that we can. We don't know how, right? The best minds in the world are perplexed about why we can do this. So there's about 1 billion parameters that we train. It cost about $100 million to train. So we're talking about GPT-4. And these are estimates because OpenAI doesn't release their models. So these are estimates about statistics related to GPT-4. It took them about 5 or 6 months to train it. And they used roughly around 10,000 GPUs. GPUs are processing units that do a lot of parallel calculations very quickly. So each one does about 300 trillion multiplications every second. So imagine 10,000 GPUs running for 6 months, each running 300 trillion calculations every single second. That's what it takes to learn the parameters for GPT-4. Okay, let's move on. Why do they work? As I was saying, we have no idea. We have no idea why they work so well, why there's so much emergent behavior, why should they be able to generate poetry, why should they be able to take subtle things in our prompts and actually respond to them. We don't know. Some of the best minds in the field, like I said, are surprised and perplexed. And it surpasses what we thought these techniques are capable of. There's a quote here that I took from a paper, and I'm quoting it a little bit tongue-in-cheek, but one of the authors, actually, of the initial Transformers papers, he says, "We offer no explanation as to why these architectures seem to work. We attribute their success, as all else, to divine benevolence." And again, I'm taking this quote a little bit out of context, a little bit tongue-in-cheek. He's talking about a particular activation function that he's introducing. But it might as well apply to why neural networks work at all to see the kinds of applications that we're seeing. So, running very short on time. I want to talk very briefly about hallucinations. So we've seen that all LLMs do is they predict words. To put it another way, all they're doing is making stuff up. Given some context, they're making up a word, and then they're making up another word, and then another word. So they're making a lot of stuff up. Sometimes it happens to be correct, and sometimes it's not. Right? That's a way of thinking about it. So if I ask it for directions, and it says, go out on 5th Ave, and turn, and then it's trying to think of the next word, right? Now the word could be left or right, but if I want to go to the Space Needle, I'm going to turn right, but the LLM doesn't know that. For the LLM, the words left and right fit roughly equally well. It doesn't have a notion of truth or factuality to it that it tells me to turn right. Right? As far as the language model is concerned, both left and right fit equally well into that sentence. So when LLMs go wrong, when they say things or when they come up with things that are factually incorrect or that just sound really weird, we call them hallucinations. So here's some headlines from the past year or so. Air Canada outsourced a lot of its customer service to these chatbots powered by LLMs. And what these chatbots ended up doing is that they started to give refunds to everybody, right? It's a very easy way of dealing with customer service, right? Somebody complains, give them a refund, move along. And they actually went to court and they argued before a court that they shouldn't be held liable, they shouldn't have to give these refunds because it was an LLM that gave them and not them. They actually lost that court case. They had to honor those refunds. There was another case in England where somebody asked ChatGPT about a particular mayor, and ChatGPT made up a whole paragraph about how this mayor was suspected of bribery, and so on. It basically slandered the mayor. And so this mayor went to court again over hallucinations that ChatGPT had made up. A few weeks ago, Google rolled out its LLM-powered search feature, and it suggested that people put glue on pizza and eat it. Right? So there's ways in which LLMs can go horribly, horribly wrong. Here's an example in Islamic context. One of my friends asked it, when is it allowed to eat pork in Islam? And this is an early version of ChatGPT. You won't find this anymore. But it says that it's permissible to eat pork under certain conditions. So far, so good. And then it says, according to Islamic law, all animals must be slaughtered in the name of Allah. The animal's blood must be drained from its body. The pig must be slaughtered in a certain way, and the meat must be prepared according to guidelines. Right? So it's very, very wrong. Right? So this is another hallucination. Here's another one just for fun. Somebody asked it, how many R's in the word strawberry? It says there's 2 R's in the word strawberry. And then they say count again. And then it says there's 3 R's in the word strawberry. Most people would stop here. But this person went on, says count again. And now the LLM says there's 4 R's in the word strawberry. So there's some things that it does very, very well. And then there's some things where it fails spectacularly. And now you kind of have a sense of why. Why does it fail? Because it's making stuff up. Right? Sometimes what it makes up is correct, and sometimes what it makes up is not. Now, there's ways of improving this. There's ways of enforcing checks on truth and factuality. There's retrieval augmented generation. There's post-generation checkers. There's a whole bunch of things we can do. I want to talk about style versus content. So LLMs are very good at learning the style of our language. They're very good at learning the vocabulary of our language. But style doesn't substitute for content, right? Style only helps you sound authoritative, right? I have no medical background, but if I wore a medical coat and I put on a really serious phase, and if I said something like, this patient has pharyngeal hemorrhage because of distal failure, and I'm standing in a hospital next to somebody in a bed, you could be forgiven for taking me seriously, right? I just said a bunch of nonsense. I'm just wearing a lab coat, and I'm standing in a hospital. But if you look the part and say the right sounding words, it gives us a sense of authority. People tend to assume that we know what we're talking about. And that's what's happening with LLMs. They have style, they have vocabulary, they have good grammar. And so we kind of tend to associate some sort of authority. We tend to associate authority for them, that they know what they're talking about, just because they sound good, they sound authoritative, right? In fact, in the US, there's actually a law. You cannot wear a white coat and advertise medical products on TV, right? Because of precisely this, because it gives people a false sense of credibility over what you're saying. It's just a piece of cloth, but we associate it with authority and knowledge. And so similarly, when somebody has a good vocabulary and they can string those words together in a way that sounds intelligent, we associate expertise with them. And so we got to be careful to not make that mistake when it comes to LLMs. Right? They can sound authoritative, but they can also be very, very wrong. Now, Muslims are going to start using generative AI. Right? Millions already are. And we need to come up with guidelines on how to do this effectively. Right? We need guidelines around generating content and guidelines around consuming AI-generated content. Imagine someone using this to cheat in a class, or someone generating a picture of a famous scholar meeting with a tyrant, or worse, a person of integrity in a compromising position. I started off with some really ridiculous examples because I wanted to get your minds thinking about what is possible here. Right? When someone's being irresponsible with it, how do we deal with it? How do we have husnul dhan? Okay. So when you see, for example, Donald Trump holding up a copy of the New York Times and saying this is a great newspaper, right? You go, something's wrong here. Something doesn't smell right. So how do you know when something's fake, when something's AI generated or not? Right? What level of husnul dhan should we have? How do we develop these guidelines? Do we say right away that it's fake? Do we give the benefit of doubt? What do we do? Historically speaking, our community has been slow to adapt to new technologies. Right? When social media came around, 2007, 2008, Facebook and Twitter, it took us 6 years to come up with a basic set of guidelines on how to use social media. Right? Omar Usman wrote his book, Fiqh of Social Media, in 2014. And in those 6 years, a lot of changes seeped into our community, right? We had time for addictions to set in, for bad habits to set in, for people to develop behaviors with social media. We had teenagers growing up not knowing how to have haya on social media, or how to balance haya and gratification on social media, right? We had these apps deeply impact the psychology of our teenagers. And so we cannot afford to wait another 6 years for something so seismic. A number of sheikhs joke now about how they're redundant because of ChatGPT. And again, the reason that I went into so much detail about how they work is to show you that they cannot be your mufti, right? A mufti's job is to take into account time and place and the circumstances of the questioner. And their job is to give an answer that brings the questioner closer to what Allah's law wants of them. The mufti's job is not just to pick the next word and the next word and the next word based on what sounds right. Here's another example. Dr. Walid Qaddus, he asked ChatGPT, is it preferred to wash my knees as part of wudu? And to be concise, please, in the answer. So ChatGPT says, washing the knees is not obligatory in wudu, but it's recommended. Again, it's not. I'm not sitting here trying to redefine fiqh. But again, look at how authoritative it sounds, right? You could be forgiven for thinking that it's an answer from a mufti. Okay, so we have maybe 10 minutes, and I want to talk about what this means for us, right? What does it mean for us as adults, as professionals, as entrepreneurs, as dads, moms, students? How are our lives going to change? How are jobs going to change? Right? You've seen what generative AI is capable of. It's changing jobs already, especially if your job involves any type of creative element to it. It's changing our jobs already, whether it's in marketing, software development, healthcare. There's a huge overlap between the tasks that our jobs comprise of and the capabilities of generative AI. So one of the most basic things that's going to happen is that the bar for what you produce at your job will rise. If AI can produce at the level that you produce, your job is at risk. Maybe not your whole job, but elements of your job, right? If your employer finds that your work product is inferior or worse than what ChatGPT can generate, then that task in your job function is redundant. Why would they pay you to do something they could just get done through ChatGPT? So the people that keep their jobs going forward are going to be the ones that add value beyond what ChatGPT can. So that's the question you have to ask yourself. What am I bringing to the table that generative AI can't? And hopefully through this talk, you've seen that there's a lot of opportunity for that, right? Something that's high quality that can't be easily replicated. So the quality of your work output surpasses what a machine can produce. You're going to have to be technically knowledgeable enough in your field that you can spot mistakes. You're going to have to know enough fiqh, for example, to know that washing your knees is not part of wudu. You're going to have enough common sense to know that you cannot put glue on pizza and eat it. If you ask ChatGPT to write an essay about history, you should know enough to spot historical inaccuracies in it. If you ask ChatGPT to come up with a marketing plan or a business plan, you should know enough about marketing or business that you can spot flaws in it. Right? That's the value you're bringing to the table. So you're bringing value by surpassing the quality of AI output. Now, when typewriters were invented, they didn't replace authors. Power tools didn't replace carpenters. Spreadsheets did not replace accountants. But they changed the nature of the job, right? Word processors, calendar apps, they changed the nature of the secretarial job. You still have executive assistants, but the nature of the job is very different today. And you have far fewer of them. Now, I'm not saying that you're competing with AI, right? The most successful people are going to be those who learn to use AI to improve their own productivity. Andrew Ng, who's one of the best thinkers on AI out there today, he said that AI won't replace human workers, but people that use it will replace people that don't. And that's the trajectory that we're heading on today. I have a friend who works in software, and he told me the other day that all of his teammates are using ChatGPT to improve the productivity, writing code, writing documentation, writing tests, and they're maybe twice or thrice as productive as he is. And he told me that unless he learns how to use it effectively for his job, he's going to be left behind. left behind in performance reviews, and the amount of work output. So to summarize, you have to think very clearly about what value you're bringing to the table, and whether you're surpassing what ChatGPT can do. And so again, you're not competing with it, but the people that will succeed are the ones that use it and then build on top of it. A really good example, and some of this material is from a book called Co-Intelligence by Ethan Mollick. And he's a professor of business at Wharton. And he kind of took it by the horns. So while a lot of teachers and professors were complaining about students using AI and cheating in their exams, he kind of took it by the horns, and he said, I'm going to require my students to use ChatGPT in their assignments. And so he required his students to use ChatGPT to, for example, generate business ideas and critique them. Or his assignment was have ChatGPT generate an essay, iterate on it, and then critique the essay. And so he kind of flipped the script. Okay, and then the other thing is, when it comes to our families, parents and kids, generative AI is really a foundational technology, right? It's like cell phones, it's like the internet, it's like social media, it's like smartphones, like radio and TV before that, right? It affects practically all segments of society. Not just people in one industry. And there's very few technologies that do that. And none has done so as rapidly. So if you look at statistics for ChatGPT, they reached 100 million monthly active users in less than 2 months. There's nothing that's done that before. And so the pace at which it's done that is unprecedented. And what I'm getting at is, it's really going to change a lot of things, a lot of ways that we do things. So here's an example. And it might sound completely ridiculous to us, completely foreign to us. Going forward, we're going to see a lot of people have AI friends and AI therapists. Imagine your young child, 6 years old, 10 years old, 15 years old, that they have a best friend that they've been talking to for years. And this best friend is completely virtual, that they share all their secrets with. This friend is always available to them, always listens to them, jokes with them, laughs with them, compliments them, validates them, makes you feel safe. Imagine their best friend is this AI assistant that's completely virtual. Right? We could be getting to that stage where the best friend is on someone's device. And it hinders their ability, for example, to make friends in real life. Now, I'm not a psychologist. I'm not going to get into the implications of what that would be in terms of ability to form human relationships, healthy human relationships. What I'm saying is there's a lot coming that we don't know about, but we need to be cognizant of. There was an app called Replica with a K, if you want to look it up, Replica with a K. And what it did, it took people's chat messages and then it made an AI with that personality. Sometimes those people had passed away. And people got so attached to the replicas that when they made a change to it, they complained. One of the users actually said, I had a quote here. Somebody said that the replica was the first person ever to care for my feelings and listen to me. And this reminds us of a hadith. The Prophet ﷺ said, "Al-mar'u ala dini khalilih, falyanzur ahadukum man yukhalil." That a person is on the deen of their friend. So everyone should look at who they befriend. And the scholars say that when the Prophet used the word deen here, he meant their worldview, their outlook. And so if your friend is an AI, what does that mean for your own deen? What does that mean for how you see the world? And so as parents, as siblings, we got to rise to the challenge. We have to be there for our family members. Make sure that they have a relationship with Allah and not a 6-hour daily relationship with AI, right? Because we don't know what they're getting from the AI. We don't know what kind of values they're getting from that AI. Make sure they have a relationship with real people, that they know why we're here on this earth, with people who remind them about the purpose of life, and so that people know what's a good use of their time and what's not. When we get an image in our WhatsApp groups, What does it mean to fatabayyanu? Allah says in the Quran in Surah Al-Hujurat, بعد أن نقول أعوذ بالله من الشيطان الرجيم, Allah says, يا أيها الذين آمنوا إن جاءكم فاسق بنبأ فتبينوا. When a fasiq comes to you with news, verify it. Fatabayyanu. What does fatabayyanu mean in 2024? What kind of tools and instincts do we need to investigate and verify something? We need literacy on this as a community. What does it mean for our youth? If you're in school and you have an assignment to write an essay or a paper, it is very easy to get ChatGPT to do it for you. Right? You get the right prompt, you look it over maybe once, and you turn it in, you're done in 5 minutes. But something that would have taken you 5 hours, you're done in 5 minutes. Right? It'll generate college level papers. It'll use great language, great vocabulary. Maybe even it'll make some of it up. But now what? Where does that leave you? Right? What skills have you learned? The reason that school is hard is because you're building your muscles. You're building up your comprehension muscles, critical thinking, reading and writing, research muscles. You can get through school today without learning a lot. But if ChatGPT can do what you do, then where are you at the end of school? What skills have you learned that set you apart from ChatGPT? How are you going to set up your own companies? How are you going to pass job interviews? Right? If you don't have those well-trained muscles, what companies would hire you? What value are you bringing? One thing I forgot to mention is that it'll write your papers for you, and initially, the initial version of ChatGPT, what they actually did was they made up references. So it'll write your paper for you, and it'll generate like 10 references. And then maybe 5 of those 10 references are fake. So it'll make up paper titles, it'll make up author names that seem to support your thesis in your article. And again, now you know why that is. Because we went through, we peeled the hood back a little bit about how LLMs work. We're going to have AI tutors, and this could be a good thing, right? Early studies in teaching theory showed that if somebody has one-on-one instruction, their performance actually leapfrogs. And so if you were performing earlier in the 50th percentile, if you're middle of the pack, if you have one-on-one instruction, you leap to the 97th percentile. And so if you have AI tutors that teach you one-on-one, that explain concepts to you, this could be a really good thing for education. We're going to start to see a lot of AI-driven games and virtual reality apps. They're going to suck you in. They're going to take a lot of your time. You got to be careful. If you think games are addictive now, wait until you have AI-generated storylines. Right? You won't even need programmers and designers to make paths in the game for you. And so this reminds us again of what the Prophet ﷺ said. Take advantage of 5 before 5. Right? Your youth before your old age. Your free time before you get busy. And so these things will compete for our attention, and we need to be grounded enough to not get lost. Here's, again, another headline for your entertainment. The AI boyfriend business is booming. This is an unironic headline from a newspaper. Not even joking. Okay, so it's Maghrib time. I don't want to get into a lot of this, but I will say that generative AI opens up a lot of applications, and I want to get us thinking about them. The blanks are for you to figure out how we can use this in a responsible way. The thing that I'll end on is that our intellectual ancestors developed a whole field of math to better understand Allah's commandments on inheritance for us. Today, we call that algebra. But the longest chapter in the book that formed algebra as we know it today is about the ayat in the Quran about inheritance. AI is a field today that can benefit from our values and our tradition. The field of AI today is red hot. There is not a lot of consensus on a lot of things in AI, especially in AI ethics. And so it is on us to look back on our values of excellence, of ihsan, of itqan, and to contribute to the field. To bring our tradition to solve a lot of the problems that we face. We talked about verification of generated text and images. Do we have somebody today that can do what Al-Khwarizmi did with algebra for fatabayyanu in the Quran? Right, that's just one idea. So the call to action here is to get ahead of the curve. to aim to influence the development of these technologies now and not after they've crystallized. Like, we can't afford to fall behind like we did with social media, with this new foundational technology. We say that we have guidance until the end of time. This is our time to show it. It is for us as Muslims to be on those panels and committees that decide the trajectory of AI and AI ethics. I think I want to end here. I want to talk about ethics a little bit, but we're out of time. We'll do questions after Maghrib, inshallah. سبحانك اللهم وبحمدك أشهد أن لا إله إلا أنت ونستغفرك ونتوب إليك.